Okay. Right, we'll start. Good evening again. Right, sorry for the delay. The thing is, I don't know whether it's something wrong with my YouTube account. Now, this happens for the second time today. When I put on a live on YouTube, two duplicates lives are created. Right? In last Thursday also, the theory batch, they know, same thing happened. Right? When I stream on YouTube, same live is duplicated. If one is deleted, both gets deleted, right? So today also the same thing happened, right? And now today one live is automatically ended, right? That's why I had to check again, right? I think it's fine now. I'll check whether it's something with my end, right? So first day I thought it's a bug or glitch or something from YouTube, but today again it happened for the second time. Okay, right, we'll start. Okay, listen. So first thing is, this week I have to close all the submissions by, last week I had to close all the submissions by the midnight of Friday because you wrote an essay paper, right? It was a full essay paper, consists of 4 structured essays and 4 essays, right? So usually to mark such a paper, it takes around 30 to 40 minutes of time, right? So that's why I had to close the submissions by Friday night, by Friday midnight, right? Otherwise, if it was a MCQ, in last week also I allowed you to submit on the Saturday as well, but this time I had to do that way because otherwise I'll be running out to mark papers, right? Now even today also, I didn't get any time to upload your marking sheets, for the online ones, to upload your answer sheets yet, right? So I'll do it during the class if I get time. If not, I will upload it after the class. And I didn't get the rank list yet, right? Because what actually happened was, the main one who is doing marking was kind of busy this week due to some other thing, right? So therefore, that's why it happened, right? I will get the list in the class, during the class. So once I get the rank list, I will give you the ranks. And for the online ones, for the physical ones, I gave you the mark papers, right? For late submissions, I will consider during the week, right? It won't be in the rank list now since it was late. And we'll get the rank list during the class. Once I get the rank list, we'll give you the rank list, right? So until I get the rank list, we'll go to the discussion, right? All right. Let's see. What? By 4. Marks are given out of 200, right? Marks are given out of 200, right? This was a full paper you wrote, right? Listen. I will update the marks accordingly for the online ones. For the physical ones, if you need to do the sum, the final mark is given out of 200, right? Why? What's the reason? You wrote 4 structured essays. One structured essay is 20 marks, right? So here you have 80 marks. Now this is a full paper, right? Here onwards, you will be having full papers only, right? And 4 essays. One essay carries 4 essays. One essay carries 30 marks. 30 into 4, right? 120. So that is 200 altogether. Final mark is given out of 200, right? To get the final mark, right, what you can do is divide this by 4, right? Now as an example, if you have got say 180, right? 180 means you have got 45 marks out of 50, something like that, right? So if there is say 120, right, then 30 marks out of 50, something like that, and add it with the part 1, right? This thing over 4 plus the final mark of part 1 is the final grade for the paper, right? Okay, so just wait until I get the rank list, right? Until we are getting the rank list, we will start the discussion. Once I get the rank list, I will give you the ranks. So that's the exact reason I had to close the submissions by Friday, right? Then සමහර අය 3යි ඔතනත් ඔන්ලයින් එකෙත් මම හිතන්නේ දෙන්නෙක් තුන් දෙනෙක් නැහැ. එහෙම නැතුවත් මාක් කරගන්න අමාරු වුණා. Right, let's see. Now it's working fine, right? Right. Right, let's see. Question 1. Go to question 1. Question 1. Right, go to question 1. It says, and before that, how was the paper? How are we? Online? How was it? How was the paper? This is the first paper you wrote as I mean four structured essays and 4 essays, right? And in all other ones, second parts consists only of 2 structured essays and 2 essays. How was it? Until it's graded. Other than that. Right. Online. What about you? Raise your hand. Online students, huh? Raise your hand if the paper is hard. Online. Raise your hand if this paper is hard. And I put a sonometer question as well because we discussed in the practical seminar, right? One sonometer question. So no one raises hand, which means it is easy. Is it? Okay, then raise your hand if the paper is average. Average. Online? All right, we'll start. Question 1. A metal sheet with a circular hole of radius d. It is not radius actually, it is diameter. Now when it is marked, since d is marked in the diagram, I considered it as a diameter, right? Right, even though it's given as radius, it is marked and it is given as d. Radius d, right? So therefore, assuming that you all have that common sense, I considered it as a diameter, right? Diameter mark right? Radius, if the radius is given, it should be given as r. That is one thing. And in the diagram given, d is marked, so it should be the diameter. Okay. The length AB and D are of the order of few centimeters. T less than 10 centimeters. The thickness of the sheet is of the order of few millimeters. What is the most suitable measuring instrument to measure the thickness of the metal sheet? That is few millimeters, it says. Question 1, part 1. Question 1, part 1. Question 1, part 1. It says thickness is few millimeters, no? Then what is the suitable one to measure the thickness? Micrometer screw gauge, right? So when measuring something like a metal sheet, we are actually more towards the micrometer screw gauge. The other reason is that is the only instrument you can get an indication about the proper tightness. Otherwise, if you are going to use something like a spirometer or maybe a vernier caliper, we don't have any idea or any indication about how properly it is tight between those two. No? In a micrometer screw gauge, we have a proper mechanism. So, which means without damaging the sheet, without damaging the thickness of the sheet, you can stop rotating the thimble when ticking sound is coming from the thimble head. Right? So therefore, always keep that in mind when you measure something like metal sheets, metal wires. Right? We are always more towards micrometer screw gauge. Right? So the first one, micrometer screw gauge. Micrometer screw gauge. Second one. What is the important experimental step that should be carried out before using the above instrument? What is it? It's A and B. A and B. What's it? Huh? Checking zero error, right? Checking zero error, that's it. Right? You don't need to explain. Don't need to explain, no? Just write down checking zero error, that's it. Experimental step. Checking zero error. Right? So no need to explain how zero error is measured here. Always for structured questions, you have to write concise answers. Right? Concise I have explained. Concise means to the point, and it should be like short and sweet language. Short and sweet answers, concise answers. Right? Should be to the point. Right? See, the above measurements were taken using a vernier caliper. State which parts of vernier caliper should be used to measure each of the following dimensions. A is a length, no? What can be used? External jaws, right? External jaws. External jaws. B is also external jaws. That's also a length. Width, no? External jaws. D is an internal diameter of a hole. That's a hole, right? Then you have to put internal jaws into the hole and get the internal diameter. That's an internal diameter. For that, internal jaws. Right? D. What is the most suitable laboratory instrument to measure the mass of metal sheet? Right? First check whether is there any hint given about the mass. Nothing is given, no? Nothing is given. Then the question is open. You have to focus on accuracy and give an answer. What's the most suitable instrument? It says a thin metal sheet, right? No, it doesn't say thin, but it says thickness is few millimeters, right? Thin කියන වචන use කරන්නේ, the word thin is not used, but we know that is few millimeters. And lengths are also less than 10 centimeters. That's a small sheet. Okay, what's the best one? Tell me. Electronic balance. Good. What else? Electronic balance is correct. Electronic balance. What else? Or else 4-beam balance, not the triple beam, 4-beam. Electronic balance or 4-beam balance. 4-beam balance or chemical balance. Chemical balance. මේ තුනම පුළුවන් chemical balance. Right? So if you have written any out of these three, it is correct. E. Using the above measurements and standard formula, write an expression for the density of metal. Right? Mass is given as simple m in the above one. Density is asked. To write density, first hand you need volume. Right? Mass is m, no? It's given. Then you need volume. How to write the volume here? Right? See? Now, if anyone can write this at once, totally fine. Right? I'm just writing the volume separately for you to understand. Volume can be written as cross-sectional area into thickness, no? Volume is cross-sectional area into thickness. Cross-sectional area of the sheet is, total area is A times B, right? Minus the whole. Whole is a circle, pi r squared. Then phi radius is d over 2 squared, right? This whole thing into, this is the area into thickness. Thickness is given as T, right? Thickness is T. This is the volume. If volume is known, density is rho equals m over v, no? Right? So density is m over v. V is here. V is here. AB minus pi d squared dou 4 times T. Final answer. F. Measurements obtained at several places for the thickness of metal sheets are given below. 3.50, 3.51, 3.52, 3.51, 3.53. What is the least count of the measuring instrument? What's the logic behind least count? If readings are given, readings are taken, no, readings can be taken only up to the least count of the instrument, right? Now you can see 2 decimals are taken, and consider the second decimal. 0 is there, 1 is there, 2 is there, 3 is there. So which means all decimals are also there. To take all decimals up to the second decimal, least count should be 0.01, right? If given readings were, listen, something additional. If given readings were, say, only the multipliers of 0.2, like 3.50 and 3.52, sorry, 3.502. No, 50 नहीं दिला दे पे. मैंने मैं वही बोला, like 3.50, 3.52, 3.54. Now in such a case, least count is not 0.01, right? That is 0.02. Now in this case, since all values from 0, 1, 2, 3 are taken, then least count should be 0.01, right? Otherwise such cases are also there, because we have least counts with 0.02, 0.2. Then only even numbers, even decimals can be there. That you have to check. Right now in this particular case, there is 0.01. F1 0.01 millimeters. Second one, calculate the mean thickness of the sheet. Mean average at these values and divide by 5. Mean thickness, simple. Mean, very simple. 3.50 plus 3.51 plus 3.52 plus 3.51 plus 3.53 over 5. What's the value? Is it 3.42? No, it's wrong. What's the value? A simple part, just the average. And 3.53. 3.514, is it? 3.514, right? 3.514. 3.514 millimeters, right? So even if you write 3.51, that is also fine. Even if you write 3.51 millimeters, right, this is also fine. Number 3. How many decimal places can be included in your answer? It is asked because you have got 3 decimal places here, right? Otherwise, there's no point of asking that question, no? That is why that particular question is asked. How many decimal places can be included in your answer? Explain the reason for your answer. How many decimal places? Only 2. Only 2, because least count of my instrument is only up to 2 decimals. Fine, then only 2. Only 2. Explain the reason. Right? Write the reason. Least count of instrument is only up to 2 decimal millimeters. Least count of the instrument is only up to 2 decimal millimeters. Least count of the instrument is only up to 2 decimal millimeters. Least count of instrument is only up to 2 decimal millimeters. Right. Take it down. Right. Any questions? Either. I got 3.515 millimeters, so I wrote 3.52. No, it should be 3.514, right? Should be 3.514 only, right? Simplify these 5 and see. Are 514 in there? Right? So 515 gonna be. So you can't write 515 there and 3.52 millimeters. Then is it correct? No. Can you explain part T again? What is part T? Part E. Oh, here. Volume. Right? First idea is volume can be written as area times thickness. Right? Area into thickness is volume, no? Right? Area into thickness is volume. Then if you have this kind of a sheet, right? Say you got you had this type of a sheet, something like this type of a sheet, right? If this area is, let's say, AB, if this area is AB and this thickness is T, cross-sectional area is AB. AB into length, height, or depth, anything, right? Can be written as volume. A simple idea, cross-sectional area into depth. Now, there was a hole inside. Then from this area, subtract the hole. From this area, subtract the hole. Hole is a cylinder. Sorry, hole is a circle. I mean, in terms of area, and into this whole area into cross-sectional into depth gives you the volume. Or else another way that you can do the same is, right, if you didn't understand that way, you can consider this whole thing as a cuboid. From that cuboid, subtract this cylinder. This is a cuboid, no? From this cuboid, subtract the cylindrical part. But this is easier. Cross-sectional area times depth times thickness. Cross-sectional area का मैं लिया करना पूरा. from total area, subtract the whole. Right? 17. Right. Any questions about question 1? Let's move on. Next one. Question 2. See? Question 2. So we discussed the sonometer recently in the practical seminar. Right? We discussed the sonometer recently in the practical seminar. But this is not the exact one we have in the guide. Right? This is a modified one. Right? Maybe a modified there. Right? This is a modified one. Changes can make a key. We'll see. Right. Question 2. Question 2. A laboratory set up to investigate the variation of vibrating frequency F of a stretch string with the tension T in the string using sonometer is shown in the figure. Using sonometer is shown in the figure. You are provided with a meter ruler, a tuning fork of known frequency, a set of weights from 100 grams to 500 grams, and paper iders. Sonometer wire A is under certain tension. Wire B is passed over a smooth pulley with a scale pan attached to its end. Wire B, right. Attached to the end. The tension of wire B can be varied by adding weights to the scale pan. Right. Part A. Write an expression for the fundamental frequency F of wire B in terms of T, tension of the wire, L, vibrating length, and M, mass per unit length. Right. So we know wire B is going to vibrate in between these two paper iders. It is going to vibrate in between these two paper iders. So first pattern is, so the fundamental pattern is this, and this length is given as L. Right? Very simple. One loop is lambda over lambda over 2 over lambda over 4. One loop is lambda over 2. Right? 2. Lambda over 2. One loop is lambda over 2 equals L. Then lambda is known. Lambda equals 2L. Right? And we need frequency. Then apply. These are wire, no? Transverse waves through wires. V equals root T over M. But we know V equals F lambda. Right? Then F lambda is 2L equals, in terms of T and M, no? Root T over M. You need F. Just subject this. 1 over 2L root T over M. This is what is expected. Right? So if you have used less number of lines compared to this, that is totally fine. Right? I'm writing all these lines to anyone in any level to understand. Right? Otherwise, if you can simplify faster, that is totally fine. And that is a skill you have got, no? That's a skill. Simplification is a skill. B. Taking T as the independent variable. That's a difference now. Right? If you can remember the general experiment we have, right? There T is not a variable in that general one. What is being varied? Huh? I'm not sure what's happening. It has stopped. Okay. So since the live is not working, I'll upload the video after the class. Not sure what's happening. And the other thing, if the recording on Zoom was not on, right? This for the online ones, right? You are the ones who see whether the recording is on or not, right? If not, please remind me to turn it on. Okay, let's see. Not sure what's wrong. Right, then listen. Rearrange the above expression to obtain a linear equation, right? Then square both sides, f squared equals 1 over 4l squared t over m. Then f squared equals 1 over 4l squared m t. This is given as x. This is given as gradient, and this is y. If you get this the other way, assuming that thinking that L is the variable here, right, you will get it once you move on to part C. C එක hint එකක් තියෙනවා, right? So let's move on part C. Wire A should be graduated according to frequency in order to determine the fundamental frequency of wire B under given tension. Graduated to frequency in order to determine the fundamental frequency of wire B under given tension. Right? Briefly explain the method used to find the fundamental vibrating length of wire A for a tuning fork of known frequency. Right? Briefly explain the method used to find the fundamental vibrating length of wire A for a tuning fork of known frequency. That is something we know from our general experiment also. If you need to get the fundamental, right? Fundamental frequency is the which length? Shortest length or longest length? Fundamental frequency. Shortest length, which means we are starting it by minimizing the gap between bridges, right? That is what you need to explain. We have to minimize the gap between bridges and vibrate the given tuning fork, and you have to keep the paper rider in the middle of the wire here, in the middle of the wire, and have to increase the gap gradually, gap between bridges gradually until paper riders are jump out, right? That is what you need to explain. Write down for C1, C1. Minimize the gap between bridges, 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 and keep paper rider in the middle of string, and keep paper rider in the middle of string, and keep paper rider in the middle of string, keep paper rider in the middle of string. Vibrate the tuning fork, vibrate the tuning fork, vibrate the tuning fork, and keep it on sonometer box. And keep it on sonometer box. And keep it on sonometer box. And gradually increase the gap between bridges until and gradually increase the gap between bridges. Gradually increase the gap between bridges. Gradually increase the gap between bridges until paper rider jumps off. Until paper rider jumps off. Right? Part 2. Suppose the following graph is obtained by measuring L for all tuning forks. Right? L for all tuning forks. Right. This is a second graph. This is a second graph. It gives us the variation of 1 over L and F. Using the above graph and wire A, describe a method to determine the frequency F of wire B when it vibrates with a length capital L. Okay, now this given graph is for A now. This given graph is for A. And determine frequency of wire B කියලා තමයි අහලා තියෙන්නේ. Then to get that frequency, wire A and wire B should resonate. Wire A and wire B should resonate if they vibrate at the same time. Right? Then what you can do is first you can get the corresponding something like this. The variation between 1 over L and F is given now. Something like this. Then for a corresponding length of wire A, that frequency can be determined. That frequency can be determined using the graph, since that is known. Right? Since wire A and wire B resonate with each other, this frequency will be the frequency of wire B as well. No? Right? That is what you need to explain. Write down. No need to draw this. This is for your purpose. I mean, your clarity. Write down. Respective frequency for a given vibrating length. Respective frequency for a given vibrating length. Respective frequency for a given vibrating length. Yes, we're doing the same as on Thursday. Same thing. Possible going to the so right. What is it? Respective frequency vibrating length can be obtained using the graph. Using the graph can be obtained using the graph. Since wire A and wire B, since wire A and wire B, since wire A and wire B, since wire A and wire B resonates vibrating frequencies of vibrating frequencies of B and A, vibrating frequencies of B and A should be same or are same or should be same. right? D. D. Having found simple F, draw a rough sketch of the graph between F and T on the given axis, considering the result obtained in part B. Considering the result obtained in part B, another verification, right? Now, if you have mistaken F and L at this part, again, it can be verified at this part D, right? Using the result in part B, you have to plot what? F and T. You have to plot F and T, right? Having found F, so the variation between F and T. Right? Now here, whether hint now here it is not given whether it is F4, F squared or what it is. These are just variables. And here it was given as we are going to plot a y equals mx. Then this is not F, this is F squared. That is something you have to decide because we know it from here. Right? So in the part, only the variables are given. It doesn't mean whether it's F4, F squared, or 1 over F4, 1 over T. That we know from here. Variables are F squared and T. Then that is mx. Part T. E1. E1. Using the graph drawn in part D, describe how the value of M can be determined. What is M? It was introduced before. Mass per unit length, right? Mass per unit length. Mass per unit length is in the gradient. Then you can argue with the gradient. Gradient of graph. Gradient. So let's assume gradient as M dash because M is already given. Gradient equals 1 over 4L squared M, right? Then simple M equals 1 over 4L squared gradient, right? Then you have to write this by using gradient of graph, put a comma and write this down. By using gradient of graph, put a comma and write this down. One, two. In order to obtain fundamental resonant lengths for all the tuning forks, the tension in wire A must be adjusted. Would you choose the tuning fork with minimum frequency or the maximum frequency? Explain your answer. To obtain the fundamental resonant length, fundamental is the shortest length. Shortest length is respective to maximum frequency. Then you have to start with the maximum frequency, right? So this is something we already know about the frequency and the length. Always length and frequency are inverse. Length and frequency are inverse, right? Then write down, explain your answer with minimum frequency or maximum frequency. Then answer should be with maximum frequency. With maximum frequency. With maximum frequency. Explain now. Explain with maximum frequency. Explain. Since frequency and length are inverse proportional. Since frequency and length are inversely proportional. Since frequency and length means vibrating length, are inversely proportional. Maximum frequency should be used to obtain. Maximum frequency should be used to obtain. Maximum frequency should be used to obtain maximum frequency should be used to obtain maximum frequency should be used to obtain minimum length corresponds to fundamental frequency. Obtain minimum length corresponds to fundamental frequency. Right. Next, wire B vibrates at 480 Hertz under certain tension. The minimum resonant length of wire A corresponding to resonance with wire B is 23.7. Right. So it says, now say this is wire A and wire B. See, wire B and A, right? Something like this. Wire B vibrates with 480. So this vibrates with 480 Hertz under certain tension. The minimum resonant length, let's say this tension is T under certain tension. The minimum resonant length of wire A corresponding to resonance with wire B is, right? This is given now. Length of wire A 23.7 centimeters. 23.7 centimeters. Right? If the length of wire A is increased slightly, and if the length of wire A is increased slightly, and both wires are vibrated together, a beat frequency of 6 Hertz is heard. Okay. Find the new length of wire A. Right. Find the new length of wire A. Okay then. If they resonate, which means this is also initially, yeah. Initially it vibrates with 480, no? Right? Initially it vibrates with 480. If the length is increased, right? If the length is increased, what about the frequency? I explained before. Frequency and length are always inverse. If the length increases, frequency decreases. Which means if 6 beats are heard, new frequency of this wire should be 474 Hertz. This is a decision you have to make because it says length increases. Right? This is a decision you have to make because we know length and frequency are always inverse. If length increases, frequency decreases. Right? Otherwise, now if you did the other way, like 480 and 486, if you consider, right, you won't get an increased length as the final answer. Answer right? You should be able to decide. It says it is slightly increased. Length increases. If length increases, frequency drops. Frequency decreases. Frequency decreases. Okay, now we can apply equations considering these scenarios. First one says 480, no? Right, 480. Equation. From the first one, first answer, we have an equation with us anyway. Right? First answer. Volume answer. Part 1. First use no, if needed, you can use the answer we obtained in the first one. Right? Fundamentally game scenario, this scenario is given. Right? Use if not, lambda is given. I mean lambda over 2 is given, which means lambda is known. Right? Same thing. Lambda over 2 is 23.7. So lambda in the first scenario is, say lambda 1. Lambda 1 is 2 times 23.7. Right? And in the second scenario, let's assume it has lambda 2. Then lambda 2 over 2 should be new length, let's say L. right? The new lambda is 2L, right? Then this is about the same wire. This is for wire A. For A. This is the same wire. If there is the same wire, M is same. And we know tension is given. Na? Under certain tension, it says tension is given. If both P and M are unchanged, which means V is unchanged. V should be unchanged, no? Because V equals root T of M. V equals root T of M. Now for wire A, T is unchanged. M is unchanged, same wire. Which means V should be unchanged. V should be unchanged. Right? Simply, then V equals V in both cases. First case, F1 lambda 1. Second case, F2 lambda 2. F1 480. And corresponding length is lambda. Corresponding lambda is 2 into 23.7. Right? F2 is this 474. Lambda 2 is 2L. 2 cancels, 2 cancels, and these 2 cancels. If this was 237, this is exactly 2. Then this is 20. Right? So L equals 480 over 20. 0 to 0 cancels. L equals 48 over 2, 24 centimeters. See? Increased length, a slightly increased length, 24 centimeters. centimeters. Right? Finished. Any questions about question 2? Right? Yeah. However, okay. Online? Raise your hand if it's clear. Online. Raise your hand if it's clear. Okay. Right. Good. Okay. Next. So before question 3 and 4, I will go to question 5. First essay. First essay. Question 5. 5 part A1. Right? A balloon is moving vertically upwards with a uniform velocity of 15 ms minus 1. A stone is freely released from the balloon at a height of 200 meters above the ground. Right? Stone is freely released from the balloon. Right? From the balloon, which means balloon is moving with 15 ms minus 1 already. Right? We discussed about parent bodies and sister bodies. Right? Balloon is the parent body. Balloon is a parent body. Parent body travels with 15 ms minus 1. With respect to the balloon, the stone is released from rest, which means the stone also acquires, it immediately acquires the velocity, direction and magnitude of velocity of balloon, the parent body. Right? It is at rest with respect to the balloon, but it is not at rest with respect to the earth. Right? That is the first decision you have to make. At 200 meters above the ground, at the same instant, another stone is thrown vertically upwards from the ground with a velocity of 15 ms minus 1. Right? Thrown vertically upwards from ground. Okay. See? So first, sketch what is given. Otherwise, you won't get any idea. Say ground is somewhere here. And this balloon is 200 meters above. Balloon is 200 meters above. And the stone is released from the balloon. Balloon is moving upwards with 15 ms minus 1. Then the stone immediately acquires the direction and magnitude of velocity of balloon, its parent body. So therefore, its initial velocity is 15. This is when t equals 0. At the same time, another object, right? Another stone, second stone, right? Is projected vertically upwards with 15 ms minus 1 from ground at the same point now, t equals 0. At the same point. Correct? Okay. So first, let's identify these two motions. It will be needed for the remainders. This one has got an initial upward velocity. Then it will go up to a certain height and reach a maximum point, and then only it comes back. So the motion of the first stone is something like this. Motion of the first stone is something like this. Right? Motion of the second stone is it goes upwards and reaching a maximum point and comes back. Something like this happens. Right? So if you consider this initial velocity as 0 at that very point, all the calculations here on are going to be wrong. Right? About parent bodies and sister bodies. Parent bodies and sister bodies. We have discussed. Right? With respect to that means that is about how someone inside the balloon sees. Right? Now, if you are traveling in the bus, right? With respect to the bus, you are at rest. Bus is moving with respect to earth. Right? Say you are seated inside the bus. If you are seated inside the bus, with respect to bus, you are at rest. Right? Relative motion means what you see. What you see. That is the idea. Right? Now, if the passenger is inside the bus, with respect to passenger means that is all about that passenger's world. Passenger's world. What passenger sees. Right? So if the passenger is seated, passenger don't see any motion of the passenger by the passenger. He is seated. Then for the passenger, he is at rest. But if someone looks at that passenger by being outside the bus, right? Outside the bus, that person sees, even though the passenger is seated, he moves, right? That is with respect to ground, right? With respect to outsider, he is moving. With respect to the passenger is not moving. Something like that, right? Another example is if you are inside the bus, right? With respect to you, if you are the passenger, with respect to you, driver of the bus is moving or unmoving, not moving, not moving, right? Now, always, if you are seated on a seat, distance between you and driver remains constant, no? Correct? Distance between you and the driver of the bus remains constant, which means no, there's no displacement. If there's no displacement, there's no velocity, there's no acceleration with respect to you of the driver, right? But if you are outside the bus, even though the driver is seated, so we can see driver moves along with the bus. That is with respect to the ground. So likewise, relative motion means that is what that particular force frame, particular reference frame is. Simply that person's world, that person's range, world, right? So relative motion okay. First one, as observed by a man on ground. See, now at the very first question, that is asked about relative motion. As seen by, as observed by a man on ground. A man on ground. Man on ground. Man on ground. Right? First one. What is the initial velocity of the first stone? Initial velocity of the first stone with respect to balloon is 0. But with respect to ground is, this man is on ground, no? Ground is this one, 15 upwards. So therefore, it should be 15 ms minus 1 upwards. Second one. What is the initial velocity of second stone with respect to this one? He is on the ground and this motion is also on the ground. Then again, 15 ms minus 1 upwards. Right? That is what this person sees. Right? This person sees that balloon moves. It travels. Then what he sees is it obtains, it acquires this 15. Right? Part 2. Part 2. What is the time taken by the first stone to reach ground? First stone is this. First stone, second stone. Time taken by first stone to reach ground. Apply S equals UD plus half AD squared at once. Upwards, S equals UD plus, so say downwards. Downwards, S equals UD plus half AD squared. Right? Downwards distance from here to here is 200. Right? U is upwards, then there is not 15, minus 15. Minus 15t. Right? Downwards, G acts downwards, so that is plus, then half, G is 10 plus 10, t squared. Right? 200 equals minus 15t. Minus 15t plus 5t squared. Whole equation is divisible by 5. 40 equals minus 3t plus t squared, a quadratic equation. 0 equals t squared minus 3d minus 40. Right? Find roots. T and t, minus 40 and minus 3, 8 times 5. Right? Minus 8 plus 5. Minus 8 plus 5. Right? This is negative. It cannot be a time. Time cannot be negative. Then it is contradictory, which means therefore t equals 8 seconds. T equals 8 seconds. Right? T equals 8 seconds. Right? Next one. What is the time taken by second stone to reach ground? Second stone. For second stone, you can use S equals UD plus half AD squared again upwards. Right? Vertical displacement from ground to ground again is 0. Right? 0 equals upwards 15t. Now, since we are using upwards, G is minus, so minus 10 t squared. Right? So this all together minus 10 times half is minus 5. Take it to the other side. 5t squared equals 15t, 1t2, t cancels, t equals 3 seconds. T equals 3 seconds. What is the time difference between the times obtained in part 2 and 3? Simple, right? Delta t, time difference is, right, 8 minus 3, 5 seconds, right? 5 seconds. Right? Write down. And ask if any questions. Clear? Clear? Are they gonna? Yeah, 26. 26. More are there? Second day. B again. Bega mother then. What are they? First part, I had I am 26 in right. Okay, let's move on. Part B. Part B. Part B. A battle aircraft is flying horizontally with a velocity of 72 ms minus 1 at a height of h equals 128 meters. A battle aircraft, right? So say this is the aircraft 72 ms minus 1 and 128 meters above, right? To attack a row of identical trucks moving along a straight road with different constant speeds. Different constant speeds. Each truck has a length of 10 meters and a height of 3 meters. A length of 10 meters, right? A length of 10 meters and a height of 3 meters. Like this. At the instant a bomb is freely released from the aircraft, the rear edge of the truck is at a horizontal distance of 125 meters from the point of release. Rear edge, right? So at this point, at this same time, now if this is t equals 0 in this story, right? Rear edge of the truck is at here, at the same point t equals 0. And at this point, this distance is given as 125 meters, right? 125 meters, right? Find the velocity of the truck if it is completely destroyed. A. Find the velocity of the truck if it is completely destroyed. Right. So let me ask you this question. Say these points of the truck are A, B, C, and D. Right? A, B, C, D. And say this is E. Okay. From these points, tell me what is the best point to attack if the truck needs to be completely destroyed. What is the best point from A, B, C, D, E to attack to completely destroy the truck? What is the best point? E. A. E. And A. We have it. What about online? Send you answers. Right? Send you answers. What's the best point to attack? That is again a decision you have to make. What's the best point to attack? Huh? What's the best point to attack from these 5 points? Or do you have any other different idea from these 5 points? What's the best point to attack? Yeah? E. Online? Quickly. Quickly. What's the best point to attack? E. Right. Listen. 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 So if we target a point like A, listen, if we target a point like A, right, at this point, when this bomb reaches this point, by the time this bomb reaches point A, truck is moving, no? So truck is not at this point. Truck is moving. So which means it is definitely going to miss the bomb. Right? So which means no point of attacking A and D. No point of attacking A and D. Because by the time when this reaches this point, the truck is not here anymore. Right? So therefore, when the target is taken, no point of targeting either A or D. Right? If E is targeted, listen, if E is targeted, now at this point it is targeting E, right? But still truck is moving. Then there's a possibility of hitting. And at the same time, there's a possibility of not hitting as well. There is a middle point. If the truck has gone a distance, or with a higher velocity compared to this velocity, right? By the time this reaches here, it won't hit the truck, right? And then B and C are remaining. Right? From B and C, yeah. Now compare E, B and C. From B and C, the best point to attack is not C, that is B. The reason is, if you take the target up to here, right, for this total range of 10 meters, the truck is vulnerable, right? For the total range of 10 meters. If you targeted E, right, only for 5 meters, it will be vulnerable. To completely destroy it, if that is in the vulnerable range for a longer period, that is better, no? Right? So therefore, best point to attack is B. Right? And C cannot be targeted. The reason is, if C is targeted, so anyway it is going to destroy somewhere inside the truck. That is true. And another thing, to reach, comparing B and C, yeah, to reach B and comparing B and C, to reach B compared to C takes a lesser time. Right? Then lower the time it takes, lesser the time it takes, it is also a point that we can consider when attacking. No? The attack කරද්දී ගොඩාක් වෙලා යනවා නම් ඉතින් එහෙම points එකක් තිබිලා එහෙම වැඩකුත් නැහැ. ඉක්මනට ගහන්න පුළුවන් වෙනවනේ, right? The quicker you attack, the quicker you destroy, right? In this vulnerable range, that should be the best point to destroy, right? So therefore, best point to attack on the truck is B, right? So this decision you have to make here. Right? So when this is attacked, bomb is reaching to the truck in a lesser time, and truck is in the vulnerable range for total 10 meters. Therefore, the best point to attack on the truck is point B. So this person should target, this pilot should target this point when attacking, right? So without making that decision, you can't write any equations. Okay, now let's see. Truck is fully destroyed, right? Then first you can find the time. Apply S equals UD plus half AD squared downwards for bomb. Right? S is from here to here. Bomb falls only from here to here. That is 125 meters. 125. Using the equation downwards, initial velocity of the bomb is horizontal. We are using the equation vertically, so this is 0. Plus half g is plus 10 t squared. Right? 125 equals half 10 is 5. 5 t squared. 5 to 125 cancels 25. Then 25 equals t squared. T equals 5 seconds. So this bomb reaches the truck in 5 seconds. Right. Then what do we need? Velocity of the truck. Find the velocity of the truck if it is completely destroyed. Okay, then if that is completely destroyed, at once we can do this if you consider the relative motion, right? Let's consider the relative motion. Listen, since both objects are moving, right? Rather than applying two equations considering two objects with respect to Earth, you can at once do this considering relative motion. Relative motion is when one of the moving objects are hypothetically stopped, right? Taken to the rest, right? Now, if this truck is at rest with respect to this one, if this pilot attacks this point, it is going to hit, no? Right? Let's assume velocity of the truck as u. Velocity of the truck is u. Now, I'm going to use this equation like this. For bomb, relative to truck. For bomb relative to truck. Relative to truck means when the truck is at rest. Relative to truck means when the truck is at rest, right? So without applying the principle of relative velocities, right? At once you can consider relative velocities if needed. If you need to consider relative to truck, which means when the truck is at rest, now truck is moving with you on ground. To make it to rest, to take it to rest, apply a relative velocity, in the upward direction. Now that is at rest, right? We discussed the same idea in Doppler's effect as well, right? Without using the formula, without using the principle, at once you can apply velocities to make it rest, and that velocity should be applied to each and every object inside the force frame. Then if this is applied as u, for this one also, this same u should be applied like this, right? And always, if you consider relative velocities, they should be circled. That is a standard. Practice that we do. If you have circled velocities, which means they are relative velocities, right? Now this is at rest, which means the relative velocity of this with respect to the truck is not 72 minus u, right? So at once use this equation. then S equals ut relative to truck, right? If the truck is at rest, distance the bomb travels is 125 plus 10, 135. Right? U is 72 minus u. Relative velocity 72 minus u. Time is 5. Time is an absolute quantity. That's not a relative quantity. Right? 5. And no horizontal acceleration for this one as gx vertically. As gx vertically, there's no horizontal acceleration. So acceleration is 0. Then this whole part is 0. Right? This divides by 5. 135 equals 72 minus u times 5. 5 times 120 can 24, 27. 27. Right? Then u equals 72 minus 27. U equals 45. 45 ms minus 1. 45 ms minus 1. Right? That's a good calculation. Right? Several decisions you have to make about the hitting point, and this is an application of relative velocities. Right? If you didn't consider relative velocities, you can consider another point, a second point of the object and bomb, and apply the same. Right? So किधर है नैन? किधर है नैन? इधर इसको है. मैं ही दलाइट इसको लेना बोला. Second part in 5th B. Second part in 5th B. 1 second. We are in part A yet. You mean part B? Right. Next one. Part B. Part B. After a few seconds, another bomb is freely released to attack another truck moving with uniform velocity of 45 ms minus 1. Right? 45 ms minus 1. At the instant of release, the rear edge of this truck is also at the same horizontal distance as in the previous case. Will this truck be destroyed or not? Give reasons to your answer. Right. Now it is very straightforward. Since we have already obtained this, when the distance between the bomb and the rear end of the truck is 125, it destroyed if the velocity is 45. Now in the given scenario, second scenario is also same distance and it travels with 45, which means again it is going to have the same scenario like this, right? Then that second truck will also be destroyed. It will be destroyed, right? 45 destroy, same distance, having same distance, so that is also going to destroy, right? So write down, will this truck be destroyed or not? It will destroy, will destroy, will destroy, will destroy, will destroy. Give reasons. According to the previous calculation, according to the previous calculation, according to the previous calculation, according to the previous calculation. According to the previous calculation, if its velocity is 45 ms minus 1, if its velocity is 45 ms minus 1, if its velocity is 45 ms minus 1, the second truck should also be destroyed. 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 Right. Okay. Right, listen. Listen. What if a velocity different to 45 was given? As an example, say in this given part, it says the truck travels with 47 ms minus 1 and asks whether it is going to destroy. How do you confirm it? 45 because we have already got 45. For sure, we know 45 is going to destroy. Right? What if something like 47 is given as an example? 47 ms minus 1 is given, and the same question is asked, saying the truck is moving with 47. How to check? How to check? How to check? What's the idea? You can apply another equation like this and check it out. See, something additional. Listen, something additional to what is given in the question, because it is highly probable to ask, right? So in coming questions also, it is highly probable to ask by giving a different velocity compared to this one. What happens? Then you should be able to do a calculation and check whether what's going to happen, right? This is how it is checked. Give me 1 minute, any questions? And think what you can do. Finding u. For finding u, consider the relative motion. For bomb, relative to truck. Relative to truck means when the truck is stopped. But if the truck is stopped, to stop the truck, apply the relative velocity in opposite direction. Right now, this is my relative velocity. This is my relative velocity. And if you apply the relative velocity to truck, to consider relative to truck, apply it to all other objects in the same reference frame. Then this becomes the resultant 72 minus u. Right? So if you didn't get this, another possible way is you can apply the principle. Right? But when using this, it is easier. If you are using the principle, this is what happens. If you are using the principle, velocity of bomb relative to truck can be written as velocity of bomb relative to earth plus velocity of earth relative to truck. Right? Using the principle of relative velocities, then velocity of bomb with respect to truck is velocity of bomb with respect to earth is 72. 72 this direction plus velocity of earth with respect to truck. This is velocity of truck with respect to earth. Rightwards u, then this should be leftwards u. Right? So this can be written as 72 minus u in this direction. So this is what you have got at once. I have got at once by doing this. Right? So if you didn't get this, you can apply this. That is fine. But getting used to this method is easier. No need to write the principle like this, right? Just apply relative velocities by circling them, right? That's it. Okay, then my question was, what happens if velocity of the truck is given as 47? 47 whether it is going to be destroyed or not? How to check? How to check? How to check? This is the logic. This will destroy if the bomb falls in the range between A to B, no? Right? The truck destroys in the range between A to B. Apply that given velocity here and check the relative displacement. Do this application again for this one, like this. See, relative to truck. S equals UD, because half AD squared is 0 now. I'm going to check S, displacement of B with respect to truck. Right? This is the displacement of B with respect to truck. This is the velocity of B with respect to truck. Then U should be 72 minus 47. 72 minus 47. Right? Into time is unchanged because anyway it is going to fall only 125 meters. Height of the truck is same, no? Alright? Irrespective of the velocity of the truck, height of the truck is same. It is going to fall only 125 still. So time is same. Right? Simplify this and see. 72 minus 47. What then? 43 ne? 43 ne? 47. Sorry, 25. 25 ne? 25 into 5. 125 meters. Which means now the bomb is going to fall here. Bomb is going to fall here. Right? It is going to just hit. Just hit. We can't say completely destroyed, but it is going to just hit on the truck. If there is 47. If there is 47, it is going to just hit at point A of the truck. Right? Can't say whether it's completely destroyed, partially destroyed. Right? So likewise, you should be able to argue. If 48 is given, definitely it is going to miss. Right? If 48 is given, it is going to miss. Right? On a 48 dollar. If it was 48, this is 48. Then 24. 24 times 5 is 120. Bomb falls just short of the truck. Not going to hit. So likewise, you should be able to argue hereafter. Right? May range vulnerable. This is the vulnerable range. This is the vulnerable range. Right? Okay. Okay, let's move on. Right. Something additional. If something like 42, 43 is given, right? If something like 42, 43 is given, again you should be able to check. Sometimes when it is 42, it might be clearing the front end of the bus. Truck. Right? Sometimes it may be missing the front end. When the truck travels, bomb might be falling in front of the truck. Right? Then you can't say whether it's destroyed. If it is missed. Right? So either way, you should be able to do these calculations if such thing is asked. Got it? Okay then. Let's move on. Okay, is it clear? Now in this part, there are few thinking parts. Is it clear? Right? Online? You can ask if any questions. You can ask if any questions. Okay then, let's move on. Right. Then go to question 8. Right. I'm going to discuss this essay from Doppler's. Right. Doppler's. So last month, not the last month, in November. November we covered, maybe a month or 2 months back, we covered Doppler's effect, right? So let's see what is asked here. Go to question 8. Right, go to question 8. Right. A physical phenomenon known as the Doppler effect is associated with wave motion. The Doppler effect has played an important role in several major scientific discoveries and is also applied in many day-to-day situations. Right. For example, bats use the Doppler effect to locate and hunt their prey. Right. So in the theory class, I discussed one such question from ultrasonic waves or ultra high frequency waves of bats. Right. A part 1. 8A part 1. Okay, briefly explain the Doppler effect. Okay, what is Doppler's effect? What is Doppler's effect? Definition is asked. Right? Then you have to write the definition with all keywords. Right? For the keywords, all marks are given. Right? Even if you write everything without using proper keywords, no marks are given. Right? Sanil, what is Doppler's effect? Hearing a different frequency from actual frequency when there's a relative motion between a source and an observer is called Doppler's effect. Right? Keywords are hearing a different frequency from actual frequency is a keyword, and source and observer are keywords. Right? Without having these 4 and relative motion, without having these 5 words, no marks will be given. Write down the phenomenon of hearing, these are theory parts, 100% theory part. Right? So if you don't know this definition, right, you can't just imagine and you can't just guess this and write. Right? All keywords should be there. Right. The phenomenon of hearing a different frequency from actual frequency. The phenomenon of hearing a different frequency from actual frequency when there is a relative motion. When there is a relative motion between a source and an observer, is called Doppler's effect. Right? Is called Doppler's effect. Right? Different frequency, actual frequency, source, observer, relative motion. These are the keywords. Right? Must have keywords. These are the must have keywords. Number 2. Describe 2 laboratory demonstrations of the Doppler's effect using neat labeled diagrams. 2 laboratory demonstrations using neat labeled diagrams. Right. So you have to think a bit. Anyone who has written any possible answers? Hmm? Triple tank is correct. Triple tank is correct. Right? Have to explain. Right? We'll explain how you can do it using the triple tank. Right? Triple tank is correct. What else? Give me 1 second. Listen. Listen. So one is triple tank. It is correct. One is triple tank. Using triple tank, we have to explain using triple tank. Right? So using triple tank, listen. In the triple tank, we have something called oscillator. Listen. In the triple tank, we have something called oscillator. Right? Usually, I mean, by default, usually in the sense by default, the oscillator is at rest. It is at rest, right? Now, if you need to observe Doppler's effect, you can move the oscillator, and in the ripple tank, always the respective wave fronts are created, no, right, on the water surface. Then you can see the wave fronts on the water surface. You can see the wave fronts on the water surface. Now, if I use a diagram, if the oscillator is like this, say the oscillator is like this oscillator, and so on the ripple tank, you will see on the ripple tank like this, you will see the wave fronts, right? So when the oscillator is moved with the velocity, right, with the velocity for this side that we explained in Doppler's effect. Now it is like this oscillator is, this is the oscillator now, that's the source now. Source is moving towards the observer at rest. Then for this side, frequency increases. Make it moving towards. If someone is at this side, right, and if someone is at the other side, right, just assume if there is an observer at rest at this side, now the source is moving towards the observer. A higher frequency is heard. Higher frequency means for this side, higher frequency, lower lambda, right? For this side, lower frequency, higher lambda. So therefore, what you will see here is this is a lower lambda with a higher lambda here. So you will see something like this, right? This is the diagram expected, right? Write down. Describe karana kela now you have to describe, right? First, take the diagram, take down the diagram, then we'll describe. Right? Now I have drawn this wave fronts with respect to the direction of velocity here. If the direction of velocity is opposite, this diagram is also going to be opposite. Okay, write down below. This is the explanation. Write down below. When oscillator of triple tank, when oscillator of triple tank is moved with a velocity a change in wavelengths can be seen on ripple tank, which confirms a changing frequency and Doppler's effect. Which confirms a changing frequency and Doppler's effect. Right? Okay. Second one. Two demonstrations. No? What is the second one? Any other answers you have written? Online? Any other answers you have written? A demonstration. No? Something like this. Listen. From the laboratory, we can get two identical tuning forks. No? You can get two identical tuning forks. You can find two identical tuning forks, right? Identical tuning forks emit same frequency, right? And vibrate these two together. Listen, vibrate both of them together, right? Listen. Say, assume this tuning fork is 512 hertz, and you are vibrating both of them together, right? What's happening if both are vibrated together? Is there a resonance? Is there a resonance? Yes or no? Is there a resonance? If both are vibrated together, is there a resonance? If both are vibrated together, right? Both vibrates with same frequency, no? 512 because identical. 512. Right? So which means there is actually resonance. But even if you vibrate only one, the same thing happens. They can vibrate can own it, na? Because even if you vibrate only one, just by only one, the other one will resonate, no? Common resonance, you know. Resonance, you know, it resonates. Either way, it resonates. And what happens if two different frequencies are vibrated together? If two different frequencies are vibrated together, what's happening? Is there resonance now? No. Now you will hear beats instead. If there are two different frequencies, you will hear beats, right? Then, so in this scenario, what we can do is, if both of them are at rest, right? If there is no relative motion, then they are vibrating with the same frequency, right? We are not going to hear any beats. Beats are same frequency now, right? So if one is moved with a velocity, to one direction, then frequency reached here will be different from the actual frequency. When that frequency is different, whether it's higher or lower, there's a slight difference between two frequencies. Then it is going to hear beats. Then you will hear beats. When this is done. Right? You will hear beats. Hearing beats means, so for sure we know we have taken two identical tuning forks, and if you are hearing beats, which means frequency has changed. Then only beats can be heard, right? Frequency has changed. If there's a change in frequency, that is about Doppler's effect. There's a relative motion between these two, right? Another simple experiment we can do in the laboratory, right? Okay, take this down. Take it down. First, then describe. Take two identical tuning forks. Take two identical tuning forks. Take two identical tuning forks. Take two identical tuning forks and vibrate both of them together and vibrate both of them together and vibrate both of them together. Vibrate both of them together, right? When one tuning fork is moved along a certain direction, when one tuning fork is moved along a certain direction, beats are heard. Beats are heard. Beats are heard. Right? Which confirms that there's a change in frequency due to Doppler's effect. Which confirms that there's a change in frequency. Which confirms that there's a change in frequency due to Doppler's effect. Right? Okay, listen again, a simple experiment. Take two identical tuning forks, right? So if they are vibrated together without moving, same frequency, so you are not going to hear any beats, right? No beats. And then if you vibrate them together and if you move one tuning fork, keeping this at rest, if you move one tuning fork, keeping this at rest, only one tuning fork, then beats are heard because the heard frequency by this tuning fork due to this one is different. When there's a relative motion between these two, then beats are heard. Beats are heard means there's a Doppler's effect, right? Another simple experiment. Okay. 3. Explain the meanings of apparent frequency and real actual frequency. Well, still, this is about theory parts. This is all about theory parts. Apparent frequency and real frequency. What is apparent frequency? Apparent frequency. Apparent frequency is the frequency heard by observer when there is a relative motion between source and observer. Frequency heard by observer. Write down. Frequency heard by observer. Frequency heard by observer. Frequency heard by observer. Put to the main chat. Frequency heard by observer when there is a relative motion between 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 the source and observer, when there is a relative motion between the source and observer, right? and actual frequency emits by actual frequency means actual frequency emits by the source. Actual frequency or real frequency is the actual frequency emits by the source. Actual frequency emits by the source. Right? In the first one. About the first one. Now, this is a proved result in Doppler's effect. Then, first of all, we should know this. This is a proved result in Doppler's effect. Right? If the source travels towards the observer at rest, higher frequency is heard. If the source travels away from the observer, a lower frequency is heard. Higher frequency means lower lambda. Then wave fronts are going to decrease lambda. And about these ones also, we have drawn 4 diagrams. 4 diagrams when Mach number equals 0, Mach number is less than 1, equals 1, greater than 1. Right? Those are the things. Right? So when this travels towards, frequency increases, lambda decreases. Then this side lambda decreases, this side increases. Right? Oh, state 3 applications of Doppler's effect. So part A is all about theories. Part B is calculation. Yeah, what are the applications? Speaker? Speed guns, correct? Right? Speed guns used by police, right? Speed detectors we call speed guns, so it is called speed detectors. Speed detectors, correct? What else? Sonar meters to measure depths. Correct? What else? And supersonic jets. Supersonic means velocity is greater than velocity of sound. That is not a Doppler's effect. That is why from supersonic jets, sonic boom occurs. Sonic boom can Doppler's effect, right? Sonic boom can Doppler's effect. It is Mach number greater than 1. That is why sonic boom occurs. Doppler's effect is sonic boom again. What else? How do you know? What else? Class के अगर वो examples questions के examples चाहिए ना 3 applications bat के कलियान ना पुलो अंगे का उड़े दिला दिया ना right bat is also one example that is given but that is also a possible example right well වින්මන් ඉන්න ගන්න එකක් නෑ දන්නවත් දන්න using Doppler's effect there's a what we call it a rain not a rainfall but a rain prediction meter is there using Doppler's effect right okay mechanism එක පොඩක් වෙනස් මොනවද දන්නවද ඒක IGI ගහලා තියෙනවද IGI කියලා game එකක් තිබ්බ I'm going in කියලා right anyone who has played IGI අර IGI එකේ තියෙන්නේ මේ sphere එකක් වගේ එකක් and around that another kind of a plate kind of a thing is rotating මෙන්න මෙහෙම පොඩි gadget එකක් they are Doppler's rainfall predictions මේ predictors ඒකත් හරි in Sri Lanka also we have so even though the predictions are wrong we have the instrument we have that equipment right මම එකක් දැකලා තියෙනවා red shift and blue shift of light correct good that's correct මතකද red shift and blue shift of light okay stars ගැන මම කිව්වේ when we look at stars which are coming towards us right when you look at stars, when you observe the night sky, right? If you look at stars which are coming towards us, when it come towards, frequency increases. No, when it come towards, frequency increases. When frequency increases, we know higher frequencies are the bluish side, right? Bluish, violet side, right? Then you will see such stars in bluish colors, right? If the star travels away from us, when you look at the night sky, right? If the star is travels away from us, then frequency decreases. When frequency decreases, it shifts towards the reddish colors. Then you will see with a reddish color, right? Red shift and blue shift. Correct. Good. What else? How do you know? Me tahu udaran dia no de. Orangnya clear na. Right. And aragat thari rainfall forecaster, I guess. Rainfall forecasters. Right. Mega search kalaban. I have seen one. No, man dekat dekat dia. I have seen two rainfall forecasters using Dopplers. One is at yeah. පිදුරු දලාගල නේ. ඔය පිදුරු දලාගල එකක් තියෙනවා. right? පිදුරු දලාගල උඩ peak point එකට ගිහින් තියෙනවා. මේ peak point එකේ එකක් තියෙනවා. right? දැකලා දැකලා ඒක කවුරුත් කියලා දෙන්නේ නැහැ බලන්න ඕනේ. අර නිකන් පොඩි රතු පාට net එකක් ගහලා වගේ එක පැත්තක කණුවක තියෙන කැරක් කැරකි. දැකලා. ඊට පස්සේ ආයි මම එකක් දැකලා තියෙනවා ගොන්ගල කියලා තියෙන්නේ. නේද? මේ telecommunication points ගොඩක් ඒවා තියෙනවා. so in ගොන්ගල also ගොන්ගල කියන්නේ it's in දෙනියාය මාතර. ඒත් තියෙනවා. ගොන්ගල දන්නවද? දන්නේ නැහැ. සබරගමුනේ. right? We have this මේක ගණන් එකක්. I mean this is an expensive one and all of them are they belongs to meteorological department. number 1 තියෙන මොකද නෑ මොකද කිව්වේ ළමයි බලා ගන්නවා ඒ මොකක්ද ඒක මන් දන්නේ ඒ අල්ට්‍රාසවුන්ඩ් මම ඒක දන්නේ නැහැ ඒක රිෆ්ලෙක්ෂන් එකක් විතරයිනේ I think it's a reflection only right මම ඒක දන්නේ නැහැ අල්ට්‍රාසවුන්ඩ් ස්කෑනර්ස් නේ වගේ ඔව් ultrasound scanners වල motion එකක් නැහැ as far as I know right there is no motion in ultrasound scanners that is just a reflection right reflection එකක් and මේක හරි to measure flow rates of blood flow rates මේකට මම මීටර් එකට නමක් තියෙනවා මොකක් හරි මොකද කියන්නේ ඒක සවුන්ඩ් එක නෙමෙයි වෙන එකක් තියෙන්නේ flow rate එක කොහොමයි බයෝ මම මේක ලියන්නම් to measure blood flow rates මේකට තියෙනවා එකක් with doctors මේ නමක් තියෙනවා I don't know the name right මෙහෙම තිබ්බොත් මේ this is acceptable as an answer right doctor කෙනෙක් නෙමෙයි right this is acceptable මේ ඒකට ඕන නමක් තියෙනවා anyone who knows that name ඒකට මීටර් එකක් තියෙනවා මොකද ඒකට කියන්නේ I don't know මම අහලා නැහැ මම නිකන් stethoscope මට හෙන්නේ spirit yeah බලමු online do you know the name anyone දන්නේ නැත්නම් පස්සේ බලන්න මොකද නේ SPHIG blood pressure. If you know this technical term, you can write the term, particular term. If you don't know the term, write this way, yeah? Because we are not, we are not the biological expertise or the in that field. We know these terms. What application just know the application. Blood flow rates using Doppler's effect. And listen, this particular question came in 2015 or 16. You can check the past paper question in 2015 or 16. This blood flow rate measuring thing came. Electronics world merge කරලා ආවේ ඒක බලන්න පුළුවන්. මම නිකන් search කරලා බලන්න what is coming. It is called the flow meter. Flow meter කියලා එන්නේ. It is called the flow meter. Flow meter. Yeah, maybe. Blood flow meter. Blood flow meter. එහෙම ලිව්වත් හරි blood flow meter. Right. Blood flow meter. Is it Doppler ultrasound flow meter? Yeah. අන්න ඒක තමයි. හරි. That's the thing. Yeah. Blood flow meter කියන it's the same. Right? මම දැන් බැලුවා Google කරලා. It's same. Ultrasound flow meter is same. ඒ කියන්නේ in blood flow meter ultrasounds are used. So therefore it's also called ultrasound flow meter. Right? Flow meter තමයි term එක. Flow meter is a term. Right? මේ rainfall එක දැකලා නැත්නම් බලන්න. So you can Google and see. Right? Doppler rainfall forecasters. Something with a spherical shaped ball and another plate is rotating around that. Right? ඒක තියෙනවා. සමහරවිට ඒක දැක්කට ඉතින් ඒ මොකද්ද කියලා දන්නේ නැහැ. That is not a radar. That is not a satellite. Radar එකත් ටිකක් ඒ වගේ. If you have seen radars, radar එකත් ටිකක් similar. Right. Let's move on. So write any three, yeah. Write any three. මෙතන ඇතිව ඕන කරලා ලියන්න පුළුවන්. If something is acceptable, that is totally fine. Okay, next. B. A car approaches a fixed vertical reflector with a speed of 36 km/-1 while sounding a note of frequency 800 Hz from its horn. A man is standing near to the reflector. The speed of sound in air is 340. Right. The car approaches. This is a vertical reflector and the man is here. This is the car. Car approaches with 36. Right. First convert this 36. Right. 1805. Then 10 ms-1. So this travels with 10 ms-1. Calculate the apparent frequency heard by the man standing near the reflector. Apparent frequency heard by the man. Right? So always velocity of sound should be towards the ear of the observer. Towards the ear of the observer. This is the observer now. This is the source now. Ear of the observer to hear the sound. Right? And from Doppler's effect, for the Doppler's effect, we know we need relative velocities. You need relative velocities. Then apply relative velocities here. This person is at rest. Right? And for this 10, the relative velocity is this one, 10. Right? Then let's assume this frequency is f dash. F dash equals, first you have to write the equation in words at once in the question. Right? sound velocity through air, you have to write this. This is an essay question. Sound velocity through air with respect to observer, over sound velocity through air with respect to source into actual frequency, right? Then substitute these values. F dash equals sound velocity through air with respect to observer. Observer is at rest. If the observer is at rest, only sound velocity through air comes V, over sound velocity through air with respect to source. Sound velocity is rightwards. Relative velocity of source is 10 leftwards, V minus 10 into actual frequency. Plug these values. 340 over 340 minus 10 into 800 into 800. Right? So F dash equals 34, 33, 800. What's the value? What's the value? Eight hundred 824.24. 824.24. 824.24 hertz. 824.24 hertz. Right, next. මේ මොකද ආකිව එකත් සමහරට හරියට ඒකේ මම දන්නේ නැහැ ගන්න බබාගේ මෝෂන් එකද ඌ දඟලනවානේ ඈ එහෙනම් හරි වෙලොසිටි එකක් තියෙනවා නම් හරි right මොකද ඒකට කියන්නේ අල්ට්‍රාසොනික් අල්ට්‍රා සවුන්ඩ් ස්කෑන්ස් මම අහලා දෙනවා yeah, another example came in as what do you call it? Ultrasound scanners. Right? Another example for Doppler effect. I mean, applications for Doppler effect came as ultrasound scanners, right? To check pregnancy, right? If the movement of that baby is considered there, right? Then when the reflected wave comes to the instrument again, if the movement is involved, there's a Doppler effect, right? If there's a velocity involved, there's a Doppler effect. I think it's also correct. Is there anyone who can confirm it? Ultrasound scanners to check pregnancy. One says in the class online. Is there anyone to confirm it? I mean, having some background in the sense, if you know someone who has done it, that particular test, maybe your sisters, I don't know, කවුරු හරි කරලා දෙනවා. හරි මම දන්නේ නැහැ ඒකට බලලා ගියා. මම හිතන්නේ ඒක හරියද? Right, next. Determine the frequency detected by the driver in the car due to the waves reflected from the reflector. Then first this wave is going to reflect at this point, at this reflector. It is going to reflect at the reflector, right? Now, so one thing we can notice is this person is at rest, right? Observer is at rest, and this reflector is also at rest, which means reflector is also going to hear the same frequency heard by the observer. No? They are same if the velocities are same, right? So therefore, this is one thing we can say, right? Frequency heard by reflector. Right? Let's say there is f double dash, this equals f dash because they don't have any movement in between, no velocity. May scenario apply. So without applying it, you can easily take that answer if needed. Right? If not sure, you can apply and see, but you can take it. Right? Without simplifying, I'll keep this answer because we don't know whether it is going to simplify in the coming parts. I will keep this as 34/33 into 800 hertz. And this wave will be reflected. See? It is not a must to draw the second diagram. This is for your clarity only. Right? Now this wave is reflected. This wave is reflected from here. Right? And reflected wave travels in this direction. Right? And this Hertz frequency f double dash is emitted by the reflector. Hertz frequency is emitted, it is reflected. Right? Okay, then apply this again. Say the frequency heard by this one as f triple dash equals sound velocity through air with respect to observer. Observer in this case is the car now, and the source is the reflector now. Right? We discussed Doppler reflection. Then observer is here. With respect to observer, that is V plus 10. Same direction, no? V plus 10 over. With respect to reflector is at rest, then only V comes into actual frequency f double dash. Right? Then plug these values. 340 plus 10 is 350 over 340 times f double dash is 34/33 into 800. See, this thing cancels. So that's why I kept it without, I use it here rather than taking the decimal value. Points click. Right, have to simplify this again. Determine the frequency detected by the driver. Okay, have to simplify this again. But these two are going to cancel. 0 to 0 cancels, 34 to 34 cancels. Right? Now here 35/33. F triple dash equals 35/33 into 800. 35/33 into 800. You have simplified this? 848.48. Yeah, 848/48. 848 hertz. Right, next one. 3. Calculate the apparent frequency heard by a motorcyclist traveling behind the car. Calculate the apparent frequency heard by motorcyclist. Right, somewhere here, a motorcyclist, right, behind the car. Motorcyclist traveling behind the car, moving away from it at a speed of 54. Right. So first convert that 54. 54. 18. 5. 18 times 3 here. So that is 15 ms minus 1. So this travels away with 15 ms minus 1. Right? 15 ms minus 1. Calculate the apparent frequency heard by the motorcyclist traveling behind the car, moving away from it at a speed of 54. Right. Then how many frequencies are going to heard by this motorcyclist? 1 or 2? What are the two frequencies? What are the two different frequencies? Direct frequency from car and reflected frequency from the reflector. Right? Then apparent frequency is asked. Then if there are two apparent frequencies, you have to find both. Right? You have to find both. Right? So first one. For first one, this is the direct frequency heard by the car. Now car travels this direction 10. So its relative velocity is this. And this bicycle travels to this direction 15. And its relative velocity is 15. Right? So when it hears the direct sound from this, like this, right? First one, when hears direct sound, let's say F1, F1, right. Velocity of sound through air with respect to observer. Observer is here now. Source is here, right? With respect to observer, then V minus 15. V minus 15. With respect to source, V plus 10. V plus 10 into actual frequency 800. First one is this. V is 340. Then 325 comes here. 350 comes here. 800. F1. Right? 0 to 0 cancels. By 5, this thing cancels. 5 times 7. 5 times 16. Right. Final answer 325 times 16 over 7. What's the value? 325 times 16 over 7. There are two apparent frequencies heard. Find both. 742.85. 742.85. Make it 742.85. Right? Okay. Second one. When here's reflected sound. When here's reflected sound. Right. So in that scenario, from this reflector, this reflected sound is heard by the cyclist. Right? Travels this way. So this person's relative velocity is 15 to the right. This is at rest now. Right? So let's say that is F2. Velocity of sound through air with respect to observer. With respect to observer. Now this emits F dash. This emits F double dash. That is equal to F dash. Right? F double dash, that is equal to F dash. Right. Velocity of sound through air with respect to observer. Observer is here, so V minus 15 again. Velocity of sound through air with respect to source, only V into F double dash. F2 equals 325 over 340 into F double dash is this thing, 34, 33, 800. 1, 0 cancels, 34 to 34 cancels. Then 325 times 80 over 33. What's the value? 787.87 hertz. Right. Those are the answers. And all the calculations are in part B. Part A is all about theories. Part A is all about theories. Right. Right. Take down and ask if any questions. Right. Now, go to question 4. Go to question 4. Question 4. Right. No any questions now? Okay, let's move on. Question 4. Question 4. Measuring instruments. Measuring instruments. Okay. Measuring instruments. First one. A small sphere of mass 10 grams is placed between the jaws A and B of micrometer screw gauge as shown in the figure. Name the parts of micrometer screw gauge indicated by the letters. Right. A, B, C, D, E. Very simple. A. Yeah, A is anvil. B, spindle. C, Hmm? Huh? Sleeve or clip. Right? Sleeve or clip. That is not the scale. That is not the main scale. Right? C is not the main scale. Sleeve or clip. D, thimble. E, thimble head. Right? 1. Indicate the forces acting on sphere when it is held tightly between A and B on the given diagram. Right. So this is held tightly between A and B. Forces acting on sphere indicate forces acting on sphere. Right. Then from this side, from A, there's a reaction on a sphere, and A pushes the sphere to rightward direction. No? A pushes the sphere to the rightward direction. Then RA should be rightwards, like this, right? And B pushes the sphere in leftward direction, so RB is leftwards, right? All forces now. What else? MGX, right? Next. Next, the circular scale has 50 divisions, and B can move through a distance of 1 millimeter along the linear scale when the circular scale completes 2 full rotations. Okay, then see what it says is it moves 1 millimeter for 2 rotations. What is pitch of the instrument? What is pitch? What is pitch of a micrometer screw gauge? Pitch. Distance traveled by spindle for 1 complete rotation of thimble. For 1 rotation, for 1 complete rotation. That is a pitch. Then for 1 rotation, it travels only half millimeters. No? So that is our standard one anyway. Right? Then least count is, if anyone don't know the equation, pitch over number of divisions in circular scale. Number of divisions in circular scale. Right? So least count is pitch. Pitch is half millimeters. Number of divisions in circular scale 50, 0.01 millimeters. 0.01 millimeters. Find the reading shown by the micrometer screw gauge in figure 1. Right. Figure 1 can first figure. Right. Then we need the reading of the least count. Reading equals, we know reading is given by reading of any instrument which uses a vernier scale is given as the addition of main scale plus vernier scale. Right. So in the micrometer screw gauge, completed main scale is the visible main scale. Right. Completed main scale is a visible main scale. Right. 0, 1, 2, 3. 3.5 completed. Right. 3.5 millimeters completed. You have to know this. We have discussed micrometer screw gauge before, right? Is it? In previous essay papers, have discussed, right? So, gap between two divisions at the same side is 1 millimeter. And gap between two divisions at opposite sides like this is half millimeters. This is how the micrometer screw gauge is calibrated, right? Then from the main scale, 3.5, 1, 2, 3, and the bottom one 3.5 completed, and 11 is coincided, plus number of coincided divisions with center line times least count 0.01, right? Simplify this. This is 3.5 millimeters plus 0.11 millimeters, right? So that is 3.61 millimeters, 3.61 millimeters, right? Right? 4. 4. When A and B are just in contact, the scales of the micrometer screw gauge are as shown in the figure below. Using this information, find the correct radius of sphere. Right. When A and B are just in contact, which means that is the point where the zero error is checked. That is the point where the zero error is checked. When the zero error is checked, if main scale 0 and vernier scale 0 are coincided, there's no zero error. Now that is not coincided. 45 is coincided with the center line. That's a zero error, right? Then if 45 is there, so you have to know where the zero is. If 45 is given, if 45 is given, 45 is given here. Where's the zero? Above or below? Zero is above. Zero is above. Right? Zero is above. Because always this is calibrated in this from bottom to top in the increasing that's the increasing side, right? Like 40, 41, 42, 43, 45. That's why always we count divisions of a micrometer screw gauge from bottom to top, right? So always we count the divisions from bottom to top. That's the direction it has calibrated. Zero is here. Zero is here. Okay, if zero is above, is it a negative zero error or a positive zero error? If zero is above, that is negative. That is negative. That is negative because when you are using the instrument, listen, when you are using the instrument, we rotate the instrument towards the user like this. You rotate the instrument towards the user because this works according to right hand rule. Then to increase the gap between anvil and spindle, right? Using the right hand rule, the direction of rotation is this, direction of motion is by the thumb, right? To you to move the spindle to the right, it should be moved towards the observer like this, towards the observer. So it is supposed to start from zero here, but zero starts somewhere above. So the reading is always short. Reading is short. So that's a negative zero error. That's a negative zero error, right? Then find the negative zero error. Equation of negative zero error is total minus coincided divisions. Total minus coincided divisions into least count. Total is 50 minus coincided 45 into least count 0.01. Right? Simplify this. 5 times 0.01 millimeters. Right? That is 0.05 millimeters. 0.05 millimeters. That's a negative zero error. A negative zero error. Right? Find the density of sphere. Mass was given before as 10, right? Mass 10 grams. Right? Mass is given as 10 grams. Then density, part 5. Part 5. Rho equals MOV. Rho equals MOV. Right? And using this, first you have to correct the reading and get the radius. you have to have the correct radius, right? Before this. So without doing it here, I will do the radius somewhere here. See? Now, first I need the corrected reading. Say R dash, corrected reading is, now this is a negative error. What is the correction to be done for a negative error? Which kind of a correction to be done? A positive correction, which means adding this value. That's a positive correction. Then corrected reading is, apparent reading is 3.61 plus this reading, this error 0.05. So corrected diameter is 3.66 millimeters, corrected diameter. Then what is the correct radius? Correct radius is diameter over 2, no? Then 3.66 over 2, what's the value? 66 can 33 ne? 1.83 ne? Is it? Check these values. 1.83 millimeters. Is it? 1.83. Okay, now radius is known. Then apply it here. Mass is 10 grams, 10 times 10 to the minus 3 to convert it to kilograms. And volume of a sphere is 4 over 3 5 r cube. 4 over 3 5 r cube. R is 1.83. That is in milli. Then 10 to the power minus 3 cube. Right? Have to simplify this. Simplify this. Right? Check whether it's 3.89 times 10 to the power 5 kgm minus 3. Now we have converted. So the final answer comes in standard units, SI units. It comes with SI units. Right? Six. Is it suitable to use the above micrometer screw gauge to obtain the value found in part A? Give reasons for your answer. Value found in part E. What was the value? Sorry, it should be part. There's no E, no? 4. It should be part 4. Sorry, part 3. Reading is part 3, part 3. Reading is taken at part 3, right? The value in part 3, right? Not T, part 3. Give reasons, right? So if you need to check whether a value is acceptable, what is our approach? What is the approach? Checking? Reading or check. If you need to validate the reading, what's the approach? checking percentage error. Maximum percentage error allowed is 1%, right? Maximum percentage error allowed is 1%. So check whether the percentage error exceeds 1% or not. If it exceeds 1%, instrument is not suitable. If it doesn't exceed 1%, it is suitable, right? Say it. The taken reading is 3.61. 61, 61, right? Then percentage error equals least count over reading times 100%. Check the percentage error. Least count is 0.01 millimeters. Obtained reading is 3.61 millimeters into 100%. Right? So millimeters to millimeters cancel. Then this is 1 over 3.61. Right? So for sure this is less than 1. Right? For sure this is less than 1. 1 over 3.61. Right? 1 over 3.61. 0.27. 0.27. So percentage error is 0.27%. Acceptable, right? Acceptable. 0.27%. Give reasons for your answer. Show this, and you have to say, since this percentage error is less than 1%, since the 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 percentage error is less than 1%, the reading is acceptable. The reading is acceptable. Or you can say within brackets, micrometer screw gauge is suitable. Simply, micrometer screw gauge is suitable. Micrometer screw gauge is suitable. Micrometer screw gauge is suitable. Right. Any questions about question 4? Any questions about question 4? Okay. YouTube कैसे मोद करना है ने? ICT live stream කරපුවා ඒ කියන්නේ live stream එක කරන්නේ zoom එකෙන් මේ උතර වෙන්නේ YouTube live එකට zoom එකෙන් stream key එකක් ඔතන generate කරනවා මේ සම idea එකක් තියෙනවනේ ඒතර ඒ stream key එකෙන් තමයි මෙයා stream එක ගන්නෙ දැන් stream key එක generate වෙලා කලින් විදිහට වෙනවා right වෙලා හැබැයි duplicate තව live එකක් create වෙනවා upcoming කියන ඒතර ඒ කියන්නේ at the same time මෙහෙම upcoming කියලා එකක් තියෙනවා උඩ live එක play වෙනවා අර live එකේම duplicate එකක් upcoming කියලා තියෙනවා same thing upcoming කියලා තියෙනවා ඒක play වෙන්නේ නැහැ upcoming කියලා තියෙනවා ඊට පස්සේ ටිකක් වෙලා ගිහිල්ලා දැන් අද මම close කරේ මොකුත් නැහැ මට ඕක දැන් Thursday වෙච්ච නිසා මේ මම අර duplicate එකත් close කරන්න නැතුව හිටියා හැබැයි ටික වෙලාවක් ගිහිල්ලා අර live එකත් automatically end වුණා ඒ කියන්නේ zoom එකේ stream key එක අතෙන්ට ගියේ නැහැ ටික වෙලාවක් යනවා ඊට පස්සේ අරගේ එකක් ආවා මේ මොකද source එකෙන් එන්නේ නැහැ කියලා zoom එකෙන් එකක් ආවා connecting to live stream හරි මොකක් හරි කියලා it disconnected දැන් මට Thursday ඕක වුණා මේ ඊට පස්සේ Friday අවුලක් වුණේ නැහැ මම Friday class එකේ live stream දුන්නා Friday මුළු class එකටම අවුලක් වුණේ නැහැ ඊට පස්සේ Friday එකෙන් පස්සේ ආයෙ live stream එකක් දැන් අද තමයි කරේ අද ආයෙ අර Thursday ආපු issue එකම තමයි ආවේ මම හැමදාම කරන විදිය තමයි ඉතින් මොකද දන්නේ නැහැ කේස් එක zoom එකේ අප්ඩේට් එකක් තිබ්බෙත් නැහැ දැන් ඒක කේස් එක තියෙන්නේ මේ මම live එක restart කරොත් එම YouTube එකේ lives ගොඩක් create වෙනවා ඊට පස්සේ එන කරදරයක් දැන් මම වීඩියෝ එක අප්ලෝඩ් කරන්නම් since there's no option මම දැන් live එක ආයෙ restart කරලා වැඩක් නැහැ ඒතකොට අර කලින් create වෙච්ච ඔක්කොම ටිකත් අරගෙන තියෙනවා ලයිව් එකේ කෑලි දැන් වල කෙනෙක්ට බලන්න බෑ. ඒ නිසා මම දැන් ෆුල් වීඩියෝ එක හදලා කියන්නේ මර්ජ් කරලා තමයි දාන්න වෙන්නේ. මොකක්ද දන්නේ නැහැ කේස් එක. It should be something wrong with the Zoom. Zoom එකෙන් තමයිනේ අරකට ෆීඩ් වෙන්නේ. අර කේස් එක. කනෙක්ෂන් අවුලක් වෙන්න බෑ කොහොමත්. මං Zoom එකේ එක කනෙක්ෂන් එකක YouTube එකේ කනෙක්ෂන් එකක තිබ්බෙත් නිකන් ගානට ලෝඩ් එක බැලන්ස් වෙනවා. වෙනතරම්ම එහෙම තමයි කරන්නේ. For the first time it happens on Thursday and today it's the second time. Right. That's it. Right. Then let's go to question 6. Question 6. ICD perspective එක මොකද? No idea. ඉතින් ඒක මාර වැඩක් නේ. Thursday ඉඳන් මේ වෙනකම් බග් එක fix කරන්න නේද තියෙන්නේ. මං Thursday හිතුවා බග් එකක් කියලා. තිබ්බා? එහෙමද? දැන් මේ මං අද බය වුණේ මගේ account එකේ මොකක් හරි අවුලක්ද කියලා. account එකේ අවුලක් නම් account එකට මොනවා හරි notification එකක් කරෙන්න ඕනේ එහෙම මොකුත් නැහැ. YouTube එක කොහොමද? නෑ. වෙන්නේ නැහැ. YouTube එකේ මට මේ ක්ලාස් කරන account එක paid එකක් ගන්න requirement එකක් නැහැ. ඒ කියන්නේ ඒක මම use කරන්නේ නැහැනේ. මට ads ආවත් එකයි නැතත් එකයි. ඒකේ ක්ලාස් channel එක විතරයිනේ තියෙන්නේ. මට හිතෙන්නේ Zoom එකේ කියලා කේස් එක. හරි බලමු මම ඒක check කරලා බලන්න. Question 6. Because the thing is there are like some students who are joining the YouTube live, no? I mean not the regular class students. So if you are a regular student, you can log through the website, no? But if there are someone outside the class, there are some students who are waiting for the YouTube live. When the live is not working, there's no option, right? I'm not sure what happened. දැනුත් live තුනක් create වෙලා තියෙනවා මම දැන් බැලුවා. Now all the ones are stopped by now. හරි එකට දැන් තුනක් create වෙලා. අර upcoming එක තාම තියෙනවා. තේරෙන්නේ නැහැ මොකද්ද case එක කියලා. අනේ upcoming එකක් නැති වෙලා. එකක් 0.9 seconds, එකක් 1 minute and 13 seconds. ඊට පස්සේ අර අන්තිමට දාපු එක 32 minutes and 6 seconds. ආර case එක. ඒක කොහොමද OBS එකේ case එකක් නෙමෙයි. මලත් හිතෙන්නේ Zoom එක කියලා. බලන්න වෙනවා දැන් නැත්තම් දිගටම ඕක case එකක් කරනවා. And we are studying the reverse class on this Saturday. ඉතින් කියවන්නේ මලත් කියන්න තමයි දුනා. Saturday 10th. Right? We'll be starting the reverse class this Saturday 10th. And there we'll be starting Unit 10 Properties of Matter. Right? Unit 10 Properties of Matter. And surface tension, no? Surface tension in Properties of Matter. Unit 10. Happening on Saturday from 7 p.m. to 10 p.m. That is only online. Right? Join in. For all registered students for theory and revision classes, it will be free, right? If you are registered already for theory or revision classes, for theory and revision classes, reverse class will be free, right? Anyone else can join the reverse class as a separate class. Doesn't matter whether it's 26 or 27. Right, 27 I group with right, that's it. Pass the message if anyone. 6. Write an equation for the speed v of a transverse wave propagating along a stretch wire. Clearly define the symbols used in the equation. Transverse waves. Right. So the general equation is v equals root t over m. Introduce terms. Introduce v, t and m. V, speed of transverse wave through wire. Right? Speed of transverse wave through wire. T, tension of wire. M. What is M? Okay. Mass per unit length. Right? Mass per unit length of wire. Right? D. A straight steel wire of length 0.5 meters is fixed horizontally between two rigid supports at both ends. A source of variable frequency is attached at one end, as shown in the figure. The frequency of the source can be varied from 300 Hz to 1000 Hz. The density of steel is 8000 kg-3. The velocity of transverse waves in the wire is 350, and the tension of wire is 0.15. Right. So quite a few data are given. Assume that the length of wire remains constant. First one, find the frequencies at which the wire can resonate with the source. Right. Then first check whether it is possible with the fundamental, because it is going to start with the fundamental first now. If we know about fundamental, we know since there is a wire, in wires, the respective frequencies are going to occur as, if fundamental is F0, 2F0, 3F0, 4F0, everything. The only difference is with one end open tubes. No? They are as F0, 3F0, 5F0, 7, 9, likewise for odd nodes. Right? And F0 find the F0. So at the fundamental, length 0.5 meters. Then this is lambda over 2, no? Lambda over 2 equals 0.5. Lambda equals 1 meter. V is given. Apply V equals F lambda. For wire, V is 350, right? We need F0, fundamental, lambda is 1. Okay, F0 is 350 Hz. So that will be heard. Right? So therefore, this is fundamental. Therefore, first overtone equals 2F0. That is 700 Hz. That will also be heard because it says the range of the source is 300 to 1000. No? But the second overtone is not going to here. Second overtone is going to be 1050. No? 350 times 3. 1050. Right? Second overtone is 3F0. Then that is 1050 Hz. Out of the range, it won't be heard. So what's the question? Find the frequencies at which the wire can resonate. Then only two, 350 Hz and 700 Hz. Right? 350 and 700. 350 Hz and 700 Hz. Dylan, do you have any idea what's happening with that live thing? You knew the issue on the Thursday, no? I'm just asking because now today I'll be checking it anyway. So I thought it's rectified, though if that was a bug, I thought it is rectified because Friday it worked. Thursday ni mata me Friday class එකේ අවුලක් වුණේ නැහැ. මම නැත්තව check කරනවා මම weekend එකේ live stream මොකුත් තිබ්බේ නැහැ. මට check කරන්න තිබ්බා. මම චෙක් කරේ නැත්තේ ඒකයි. නැත්තම් මම අප්ඩේට්ස් බලුවා. මම නිකන් එහෙම බග් එකක් යනවාද කියලා Google කරලා හරි බලනවා මේ මම ඉතින් ෆ්‍රයිඩේ වෙද්දි මම හිතුවා තර්ස්ඩේ නම් බග් එකක් තිබ්බා. බග් එක ෆික්ස් වෙලා කියලා. දැන් අද ආයෙ ඒකෙන් මේ ඩුප්ලිකේට් වෙනවා වැඩි. ඒ කියන්නේ දැන් ඔක සෙපරේට්ලි ආයෙ අප්ලෝඩ් කරන්න ඕනේ. Okay. Next. හරි එතකොට frequencies are these two. Second one, find the maximum tension required in the wire. Find the maximum tension required in the wire in order to observe the next overtone within the given frequency range. Then by changing the tension, now we are going to get the second overtone to the range. To the range. Then what is the maximum value that is possible to have? 1000. Then by changing tension, if we can take second overtone to 1000 hertz, right? That is what this is about. Find the maximum tension. And tension for 1000 hertz. See, second scenario. Second overtone for second find the maximum tension required in wire order to observe the next overtone. Now these two are already observed. Then next overtone is second overtone. For second overtone, this is the second overtone, right? If someone needs to see, this is the second overtone. Second overtone, right? Then lambda of this second overtone is, now length is same, still the length is 0.5. Lambda over 2 equals, lambda over 2 into 3 equals lambda over 2, one loop is lambda over 2, such 3 loops equals 0.5. Then lambda equals 1 over 3 meters. 1 over 3 meters, right? Apply V equals F lambda again. Tension is different now. So we know V equals root T over M and V equals F lambda. And this is F2, second overtone, right? Second overtone, lambda of that respective one, say lambda 2 equals T over M. Okay, then plug these values. F2 as the maximum value, F2 should be maximum 1000 to fall within the range, right? That's the logic. It says find the maximum tension required in the wire in order to observe the next overtone within the given frequency range, right? It should be at 1000, right? 1000 latest or the last should be 1000. And lambda 2, 1 over 3, new tension, say T over M, right? So let's label this as equation 1. And considering this first case, we can write another equation, right? Considering the first case of fundamental, case and where the tension is known, 0.15, right? For the first case, again you can apply this. Frequency is 350 and lambda was 1 meter, right? Now since I have applied it already here, using it at once, right? For fundamental, this is for fundamental. This is for fundamental. 350, make my F lambda equals root T over M. F lambda 1 equals root T. T was 0.15. 0.15. It was given same wire, same M. 2. Divide 1 and 2. Divide 1 and 2. Divide 1 and 2. 1 over 2, right? This side 1000 over 3 is here, right? And here 350 and M to M cancels. Then from here root T 0.15, right? I have to simplify. 0 to 0 cancels by 5. This is 20 and 7. Right? Then 20 over 21. 20 over 21 equals root T over 0.15. Simplify T. It is 0.136. Right? Square then T equals 20 squared times 0.15 over 21 squared. Zero 0.136 it is correct. 3.136 newtons. 0.136 newtons. If needed, you can keep this answer as 1/4. That is fine. You can keep it as 1/4 if needed. Right? Part C. Part C. Part C. If the length of the wire mentioned in part B1 increases by 0.49% of its original length, find the Young's modulus of material of wire. Young's modulus. Right. Young's modulus equation එක දන්නේ නැත්නම් මෙතන පොඩි case එකක් තියෙනවා. Right? So I put the equation, I put the question, not the equation, I put the question because we have to start properties of matter, and in some schools also, in some schools, properties of matter are started no already. ඒක unit 10 එක උනත් සමහර කට්ටිය thermal එහෙම skip කරලා start කරපු schools තියෙනවා. thermal කරන්න නැතුව properties of matter කරනවා. එහෙමත් ඒවා තිබ්බා. Right? Anyway, මේ equation එක දන්නේ නැත්නම් මෙන්න මේක equation එක. This is the equation of Young's modulus. F over A equals Y into E over L. Equation of Young's modulus. Right? F is called tensile force, that's a force. A, perpendicular area. Y, Young's modulus. E, extension, and L, original length, initial length, original length or initial length. Right? Then right. If area is known, all others are known, right? Frequency, F කියලා කියන්නේ force is known. So my target is finding area. So we know other than root T over M, we can write the same thing as root T over rho A, right? So we know V equals root T over rho A. The reason to go this way is rho is given. That's a hint. Rho is given. And now my target is finding A. If A is known, I can use this equation. V is fundamental. For fundamental, V is 350. Fundamental anyway, V is given, no? It's 350, it's given. And tension 0.15. This is 8,000 A, which means A can be determined. Right? A can be determined. Then 350 squared equals 0.15. Right? 0.15. Let me write this way. This is 15 10 to the power minus 2 over 8,000 A. Right? A equals, right? A equals, I'm not going to simplify this because this is not a final answer. Final answer will be here. A equals 15 times 10 to the power minus 2 over 8,000 times 350 squared. Right? If A is known, apply this in Young's modulus equation. Right? Here, F over A equals Y E over L. Right? F is equivalent to tension 0.15. Right? Tension on the wire is the force on the wire. Area is here. It cancels 15 times 10 to the power minus 2. Right? Over 8,000 times 350 squared equals, we need Y into E. The data is given, increases by 0.49. Now in such a case, no need to plug actual values. Actual values done now as 0.5, and you can find what happens if it is increased by 0.49, right? But no need. If I consider initial length as L, increases by 0.49 කියලා කියන්නේ. If this is L, this is 0.49 L. 0.49%, then I have to consider this as 100 L. If this is 100 L, if initial length is 100 L, with respect to the initial length, it is increased by 0.49 L. 0.49%. For 100, 0.49. එහෙම එකපාරින් use කරන්න පුළුවන්. So at once you can use that way. That is easier. No need to find the exact 0.5 of exact 0.49 of 0.5. Right, simplify this. These two cancels. Right, this comes to the top. Then 8,350 squared. Right, equals L to L cancels 0.49 y over 100. Okay, simplify. y equals separate these 10 to the power 8 times 35. This is 350 times 350, no? Then 10 to the power 3 comes here, 10 to the power 2 comes here, 10 to the power 5 all together, and from this 100 another 10 to the power 2 comes, and this is 49 10 to the power minus 2. Right? 49 and 35 cancels, ne? Right, in notice. 7 times 5, 7 times 7. Right. Eight over 7 විතරයි තියෙන්නේ. හරිනේ? Sorry, 8 times 5 over 7, 40 over 7. 40 over 7. Is my simplification correct? Oh, ne? Marking එකේ මේ answer එක වැරදි again. Right? So in the marking there's a different value. This is 5.71. 5.71 10 to the power 11. It should be 5.71 10 to the power 11. Sorry, 10 to the power 9. 5.71 10 to the power 9. 5.71 10 to the power 9. Any modulus has Young's modulus, no? The units of pressure, Nm minus 2. Any modulus has units of pressure. Right. So when you refer the margin, please note that the answer given in the margin for this part should be wrong. Right? This is the correct answer. Simplify කළ බලුවනේ මේකනේ. බලුව. check කළ බලන්න මොකක් හරි mistake එකක් තියෙනවද කියලා. නෑ කැල් එකේ දාලා බලන්න. මේ හරි before the simplification whether the same thing comes. Okay, next. Young's modulus done. Part 2. The source is now removed. End A of the wire is clamped and B is left free. The wire is rubbed parallel to its length. The wire is rubbed parallel to the length. Which type of waves are going to form? Huh? Very popular. Which type of waves are going to form if it is rubbed parallel to length? Longitudinal, right? Perpendicular to length, transverse. If rubbed parallel to length, longitudinal waves, right? Longitudinal waves. Using a spread with resin, find the velocity of wave produced in the wire during this rubbing, right? For longitudinal waves, we have a proved equation as y equals root y over rho, right? Arne? Mega waves la අපි කතා කරා v equals root y over rho. Then apply this equation. Apply in the equation. Y is here 5.71. This is simplification now. 10 to the power 9. And rho is 8,000. මොකක් හරි වැලිඩ් එකක් මේකේ මිස් වෙලා වුණා නැත්නම් මේක සිම්ප්ලිෆයි කරන්න තමයි ගාන දුන්නේ. right 844.83 844.83 844.83 ms minus 1. Next. When you are writing the MCQ paper this week, right, physical ones, right, physical ones, when you write the MCQ paper this week, if the answer sheet is not given by them, ask them for the answer sheet. Answer sheet සීල තියෙන්නේ මේ සමහරලාට ඒගොල්ලෝ නමත වෙනවනේ. එහෙම වුණොත් කියලා ඉල්ල ගන්න. දන්නවනේ ඕගොල්ලෝ MCQ එකක් තියෙන්නේ කියලා. හරි MCQ එකට answer sheet එක ඉල්ල ගන්න. And you can take your paper with you. Just keep the answer sheet here. Right? 3. Calculate the frequencies corresponding to fundamental and first order tone for the wire in part C2. Right. හරි දැන් මේ වැලියු එක දාලා ආයෙත් මේ දෙක හොයන්න තියෙන්නේ. With this value. Right, fundamental. Now, one end of the wire is clamped. Then fundamental frequency is going to be something like this. One end of the wire is clamped. Only one end is clamped. Right? Then this end is free. It is clearly given this end is free. If there is a free end, there is an antinode. Correct? Free ends are antinodes. Then now lambda changes. Distance, the length is same, 0.5. So this is lambda of 4 equals 0.5. New lambda equals 2 meters. New lambda equals 2 meters. Then fundamental frequencies apply V equals F lambda. Right? V is here 844.83. Right? F naught into lambda 2. So F naught is what's value? F naught 422 point rounded answer for 2 hertz. And first order, right? First order. Same thing. Do the same calculation for the first order. නැත්නම් එහෙම ගන්නත් පුළුවන්. First order is 3 times the fundamental. Right? First order is 3 times the fundamental. Right? So without doing this, so if needed, this is the pattern here. This is the pattern here. If someone needs, right? You can do the calculation like this. Or you can say first overtone at once equals 3 times F naught. Because this is equivalent to one enclosed scenario of a tube, right? 3F naught, then 3 times 422 for 2. $1,267.26. 1,267.26 hertz. Right? That's it for question 6. Right? Different approaches of stationary waves. Right? Stationary waves වලින් last paper එකත් මම question එකක් discuss කරා. හරිනේ? reflection එකක් මම කරේ තිබ්බනේ. time difference calculation එකක් එක්ක. Linear motion and stationary waves. Goodbye. right? Okay then. And in question 3, there is a normal velocity, VT graph, velocity time graph, right? So that's why I didn't give much priority to that, right? Refer the margin, and you can ask in the support group if there's anything, right? And essay salat එකක් miss කරානේ. essay එකත් බලන්න. All right. So any questions from the questions we discussed today? Anything to clarify? Anything to clarify from the questions we discussed today? We discussed 3 structured essays and 3 essays, right? We discussed 3 structured essays and 3 essays. Anything to clarify? All good? Abhi? Online? Raise your hand if no questions. If it's clear up to here. Raise your hand if it's clear up to here. 1, 2, 3, 4. What else? Who else? Who else? Only 4. 5. Only 5. And there were 2 or 3 students who joined today for the online one. This week onwards, you can start writing the paper. Just go to the respective week. So in the week, you will see a button as now paper 7 is coming up now. Paper 7, part 1, writing and submission. Go into that, then you can download the paper and write the paper, consuming 3 hours, right? Sorry, for the MCQ 2 hours, and submit it to the same case there, and save it, submit and save. Then your submission will be submitted, and make sure you are doing the submission before Friday midnight. You can write papers from tomorrow in the sense tonight to from 12 a.m. tonight to 12 a.m. midnight Friday, right? Complete 4 days are there, right? So if any questions, you can contact me, right, for the newbies. All right then. No any questions now? Okay then, we'll wind up. And this week you are going to write MCQ, right? Answer sheet එක හම්බුනේ නැත්නම් answer sheet එක ඉල්ල ගන්න. Okay then. For online ones, anyway, no need to have an answer sheet, no, right? So that's why I didn't send that answer sheet. Online එකේ answer sheet එක කපන්නේ කොහොමත් same නේ. Okay, that's it. And this Thursday in theory class, we will be doing all the other applications of thermal expansion, right? Thermal expansion, and we'll be starting expansion of liquids. And Saturday, we are starting properties of matter. Yeah, that's the thing. And during this month, during the month of January, we will be having optical instruments seminar as well, right? For optical instruments. All right then. So those are the plans. And if there's anything regarding questions about the papers here, ask everything in the support group. I didn't see anyone using support group, right? There were someone who joined the group, joined the channel, but I didn't see anyone who asked questions, right? So if needed, you can ask. All right then. Okay, then we'll wind up. Go safe and stay safe. So this is the 31st, 30th week is ongoing, right? Before the exam. May start tonight. 30th week before the exam, right? So utilize your time. Don't waste even a minute, right? Work hard, study hard. Okay then we'll meet on the next class. Good night and goodbye. Is it raining? No.